In the previous lesson we looked at how the resistance of a conductor depended on the nature of the material from which it is made. We learnt that some metals are better conductors than others, and therefore some metals offer more resistance to electric current than others. For example, silver has less resistance than copper, which is less resistance than gold, which is less resistance than aluminium, and less resistance than iron. Now in this lesson we're going to look at how the resistance depends not on the material from which the conductor is made, but on the dimensions of the conductor itself. So for example, let's take this first circuit here. So what I've got here is a series of wires, each made from the same material and exactly the same length. And what I'm going to do is I'm going to connect the circuit to each sample and measure the current flowing through the circuit, starting with the thinnest wire, the thinnest sample, and we will see that as I change the thickness of the sample, as the wire gets thicker, the current flowing through the circuit increases, and conversely, as the thickness of the wire or sample gets thinner, then the current flowing through the circuit decreases. So we can say that as the thickness of a conductor increases, its resistance decreases. Now in this next experiment, what we're going to do is, rather than change the thickness, we're going to change the length of the conductor present in the circuit. So I'm going to take a sliding connector, okay, like that, and I'm going to gradually move it along the length of this conductor. So the length of the conductor present increases, and as I do that I'm going to observe the current flowing in the circuit, and I will see that as the length increases, the current flowing in the circuit decreases. Now the current decreases because the resistance of the conductor is increasing. So we can say that as the length of a conductor increases, its resistance increases.